Now we are going to take up fractional oxidation number. Now in many compounds, when you calculate the oxidation number, you will get in fraction. Now why you get in fraction, that we are going to explain now. First compound we are taking is C3O2. C3O2 is carbon suboxide. Carbon has actually three oxides: carbon monoxide, carbon dioxide, and carbon suboxide. The structure of carbon suboxide is carbon is having double bond with two carbon atoms, and this carbon is having double bond with oxygen atom. This carbon also has double bond with oxygen atom. Now if you calculate the oxidation number of carbon in this case, let's take up oxidation number of carbon as X. So you will get 3x minus 4 equal to 0. X will come out to be 4 by 3. That is, it is in fraction. Why it is in fraction, we are going to explain. This carbon, starred carbon, is bonded to both the side carbon atoms. Therefore, this carbon is assigned oxidation number 0 like elemental carbon. So whenever there is a bond between atom and other atom of the same element, the central atom will get oxidation number 0. Now this carbon has got oxidation number plus 2 because oxygen has minus 2. This carbon has got oxidation number plus 2 because oxygen is minus 2. Now there are total 3 carbons and total oxidation number is 4. So average oxidation number will come out to be 4 by 3. So whatever fractional oxidation number we get, that is average oxidation number of that atom in that compound. Now we are going to take up balancing of redox reaction. There are two methods used to balance chemical processes. One of these methods is the change in oxidation number of reducing agent and oxidizing agent. And other method is based on splitting of the redox reaction in two half reactions. One will be oxidation half, another will be reduction half. And we will balance each half reactions and then we will add them after balancing the number of electrons. So we will get final balanced equation. So balancing of redox reaction can be done by two methods: oxidation number method or a half reaction method. Half reaction method is popularly called ion electron method. First we are taking oxidation number. Now what are the various steps for oxidation number method? In writing equation for oxidation reduction reaction, just as for the other reaction, the composition and formula must be known for the substances, that is the reactants as well as the products formed. So if you have got correct formula of reactants and products, we can balance the equation. If your formula of reactants or product is wrong, it is not possible to balance the equation sometimes. The oxidation number method is best illustrated in the following steps. The first step is write correct formula of each reactant and product. Identify the atoms which undergo the change in oxidation number in the reaction by assigning the oxidation number to all the elements in the reaction. Now calculate the increase or decrease in oxidation number per atom and for the entire molecule or ion in which it occurs. If these are not equal, then multiply by suitable number so that these become equal. If you realize that two substances are reduced or nothing is oxidized or vice versa, it means there is something wrong. Either the formula of reactants or products are wrong or oxidation number have not been assigned properly, so check it once again. Next step, ascertain the involvement of the ions. If the reaction is taking place in water, add H ion or OH ion to the expression on the appropriate side so that ionic charges of reactant and products are equal and hydrogen and oxygen atoms are equal on both sides. If the reaction is carried out in acidic medium, use H positive ion in the equation. If in basic medium, use OH ion. Make the numbers of hydrogen atoms in the expression on the two sides equal by adding water molecules to the reactants or products wherever it is required. Now check the number of oxygen atoms. If there are same number of oxygen atoms in the reactants and products, then the equation represents balanced redox reaction. Also check the charges on both sides are equal. Next we are taking half reaction method or ion electron method. In this method, the two half equations are balanced separately and then added together to give balanced equation. Suppose we are to balance the equation showing the oxidation of ferrous ion to ferric ion by dichromate ion in acidic medium, wherein in dichromate ions are reduced to chromium plus 3 ion. The following steps are involved in this process. First is we write the unbalanced equation, ferrous ion aqueous plus Cr2O7 minus 2. This is orange in color. Ferric ion will change the color. It is pale green. It will become reddish brown. Plus chromium plus 3, which is green in color. So this is the unbalanced equation. Now we are separating it into two half equations. First one is ferrous is changing to ferric and oxidation number is changing from plus 2 to plus 3. Second, we are breaking Cr2O7 2 minus to Cr plus 3. Here we calculate the oxidation number of Cr. How? Let's take it as x. So 2x minus 14 equal to minus 2. X is equal to 12, that is x is equal to plus 6. So chromium has oxidation state plus 6, oxygen has oxidation state minus 2, and here chromium has got oxidation state or oxidation number plus 3. Now balance the atoms other than oxygen and hydrogen in each half cell reaction individually. Here oxidation half reaction is already balanced because number of atoms are equal with respect to iron atoms, but for reduction half we have to multiply it by 2. Why we are multiplying it by 2? Because it is Cr2. Next, for the reaction occurring in acidic medium, add water to balance oxygen atom and H ion to balance hydrogen atom. There are 7 oxygens, so we have 7 water. And 14 hydrogen we have added, so here we have added 14 H positive ion. Now add electrons to one side of the half cell reaction to balance the charges. If need be, make the number of electrons equal in two half cell reactions by multiplying one or both half reactions by appropriate number. Now here it was Fe plus 2 and here it is Fe plus 3. We add 1 electrons so that net charge on this side is plus 2 and net charge on this side also is plus 2, which are equal. Atoms are already equal. Now in the reduction half, here we have got 14 positive and 2 negative. That is net is 12 positive charge. This side we have 6 positive charge, so 6 electrons we have added. So charges are balanced now. Atoms were already balanced. Now what we have to do, here we have 6 electrons, but here we have 1 electron, so we will multiply this whole equation by 6. We will get 6 ferrous ion aqueous plus 6 ferric ion aqueous plus 6 electrons. Now we can add the two half reactions so that 6 electrons on opposite side get cancelled and we get 6 ferrous ion plus dichromate ion plus 14 H ion gives you 6 ferric ion plus 2 chromium plus 3 ion plus 7 water. Verify the equation contains the same type and number of atoms and the same charges on the both sides of the equation. Check, we have 6 iron, here we have 6 iron, 2 chromium, 7 oxygen, 14 hydrogen. Charge this side we have the 12 positive, 2 negative and 14 positive. That is net charge is 14 plus 12, 26 minus 2, 24. Here we have 6 into 3, 18 plus 6, 24. Charges are balanced, atoms are balanced, equation is balanced. For the reaction in basic medium, add OH ion instead of H ion.